For number 3, in the energy section, a 50-gram dart rests up against a spring that has been compressed 0.05 meters. For part A, if 1.25 joules of work were required to compress the spring, what is its spring constant? So you'd use the equation for elastic energy. So you'd get EEL equals 1/2 times your spring constant, which is K, times change in x squared. And you'd use 1.25 joules, because it gives you that right there, equals 1/2 times K times 0.05 meters squared. And that would give you a spring constant of 1,000 newtons per meter. And then for part B, what is the maximum velocity of the dart after the spring has transferred its energy to it? So you would use the formula for kinetic energy, and you'd get EK equals 1/2 times mass times velocity squared. And you would use the amount of energy given to you in part A because all of the elastic energy would have been converted to kinetic energy, so it would be equal. So you'd get 1.25 joules equals 1/2 times 0.05 kilograms, which is the mass of the dart, times your velocity squared, and you would get a velocity of 7.07 meters per second. And then for part C, if the dart were fired vertically, what height would it reach? So you would use the formula for gravitational energy, which is Eg equals mass times gravity times height, and you would use the 1.25 joules given to you in part A because all of the elastic energy would have been converted to gravitational energy. So that would equal 0.05 kilograms, which is the mass of the dart, times 10 meters per second squared, which is gravity, times your height, and you would get a height of 2.5 meters.